Hi there, my name is Tim Coulter and I'm going to give you a demo of the Truffle development framework. What you should do if you don't have Truffle at all is you should go to the Truffle GitHub page and go ahead and read the documentation. That's the best way. It'll give you install instructions, it'll give you an overview of what you can do with Truffle and talk more in detail than I'm going to give on this video. But I wanted to give you a quick example to show you how you can get started. So I already have Truffle installed. What I want to do is create a new directory which will consist of my new Truffle project. So make directory demo video. Okay, demo. So I'm going to cd into the demo video directory, and then all I have to do is run Truffle. Well, actually, first notice that obviously there's nothing in it, so I'm going to run Truffle init, and what that's going to do is create a new directory structure for me with an example Truffle project. So now that it's finished running, I'm going to type ls and notice it's given me the structure. To make things easier, I'm going to go ahead and add that project to Atom. So now that I have the project, let me give you an overview of the structure and what it's given you. Obviously there are 4 directories. There's the app directory, the config directory, the contracts directory, and the test directory. We'll start with the config directory. Now the config directory is where most of the important, or actually all of the important configuration of Truffle lives. So the most important file is app.json. Now app.json, notice that it's a JSON file with comments in it. The Atom's parser doesn't like those comments. For simplicity and ease of use, Truffle's JSON parser ignores comments, so you can leave comments to your coworkers or colleagues that you're working with if you need to describe any of the configuration that you're leaving here, that you're putting here. So I'm going to ignore this build directory here for a second, and actually I'm going to ignore deploy as well. The most important point first is your RPC client. Now, everything that Truffle does is based on connecting to an RPC client. It connects through Web3. If you haven't built an Ethereum project before, make sure you Google and check out Web3, because that's one of the main libraries that you'll use to interact with Ethereum. But you need to tell Truffle, in order for Truffle to work, in order for it to compile contracts and deploy contracts and allow you to build apps on the front end, you need to have an Ethereum client running. Now, you can use any Ethereum client. You can use Go Ethereum, CPP Ethereum. You can use Python or Java or Haskell. I mean, there's plenty of implementations. But for development, what I'm going to do is I'm going to use the I'm going to use the test RPC. The test RPC is a mock Ethereum client that uses the Python Ethereum libraries as a backend, and it works similarly to a regular Ethereum client, except it doesn't connect to a network and it doesn't do any mining. It's its own chain that you can use for development, and the transactions that you send to it are processed immediately. So I'm going to go ahead and install the test RPC through pip. So pip is the Python package manager. Pip install eth test RPC, and that's going to go ahead and do its magic. That should put the test RPC executable on my computer, and there it is. So now the test RPC client is running, and it's running on localhost 8545. So if we go back and check the configuration, notice that our RPC client is connected to localhost and 8545. Now we're ready to roll. We're ready to do everything else that we need to do with Truffle. So the next thing I want to talk about is the app directory. The app directory is where all of your app's code is meant to live. It doesn't have to live there, and I'll get to that in a second, but it can. And so notice that the app directory and the files and folders in it correlates with what's in this build configuration here. Now notice that there's an index.html, there's files being pulled out of the JavaScript directory, files being pulled out of the style sheets directory, and notice that we even have an images directory that's just in itself being copied over. So what this build system is saying is that in the instance of app.js, it's going to take the file that's in JavaScript's app.js and process this, however it needs to be processed, and create the app.js file within the build directory, which actually hasn't been created yet. I'll talk about that in a second. So, for instance, if I was to have another file, JavaScript's, we'll call it file2.js, this build process will take these two files, concatenate them together, and together they will turn into, be built into the app.js file. So note that by default, Truffle supports Normal.js, ES6, and CoffeeScript, so you can have file2.coffee, and file2 will be processed as a coffee file, turned into JS, and then concatenated onto app.js, creating this built app.js file. You can use .es6 to designate that you're using the latest version of JavaScript. The same thing is true for style sheets. So Truffle doesn't just support CSS, it also supports Sass and SCSS. And so, for instance, you can have style sheets slash file2.scss. And what this will do is it will convert SCSS into CSS, concatenate these two together, and then create the app.css built file. Now, what's important with Sass is that it also supports Sass imports, so you don't in fact have to list all of your Sass files here. You could import them as you'd like to using SCSS if you prefer. So going over this build configuration one more time, all this line is saying take the index.html file within the app directory and just copy it directly over to the index.html file within the build directory. This is saying take the file in JavaScript slash app.css, perform computation on it, process it. With JavaScript, there's actually no real processing to do with vanilla JavaScript, and then turn that into app.js in the build directory. Same thing with style sheets app.css, turn that into app.css within the build directory, and this one just directly copies over the images directory. So to show you this in action, I'm going to go back to our folder here in the terminal, and I'm going to type Truffle build. Now this is going to run the build process, no compiled contracts found. Did you deploy your contracts before building? This error can be ignored for now. I'm going to talk to you about compiling contracts here in a second. But if you look now, we have a build directory. So we go back here into Atom, build directory exists, and notice that it created the exact structure that we expected. It created an app.js file, an index.html file, an app.css file, and copied over an images directory. So the last point is this is a custom build process for Truffle. It's meant to make things simple. In fact, whenever something is named app.js, it gets special dependencies added to it to make your front end easier to build, which I will describe in a bit. However, you don't have to use this process at all. If you do not want Truffle's build process, you can simply delete this from the configuration and use your own build process like Grunt or Webpack or whatever you prefer. So the Truffle example that you get from Truffle init, the example project, gives you a contract that you can deploy. Notice that the contract doesn't do anything interesting. I'm going to leave this like this for now to show you compilation and deployment, but we will edit this later. So to compile your contracts within the contracts directory, first, make sure that all of them are Solidity files. Right now, Truffle only supports Solidity. Second, you have to, since everything is done through the RPC client, you have to make sure you have solc installed on your machine. So if you don't have Solidity installed, you'll have to go and make sure that that's installed. You can do that by either building from source, which is what I did about a week ago, or you could install it using brew or other avenues. I'm not going to go through that install here, but in order to compile Solidity contracts, you need to make sure Solidity is installed. So from there, you can type truffle compile. This will compile your contracts and write the required contract data to this file called contracts.json. Now there's a little bit of a display bug here, feel free to ignore that, but let's go take a look at the file it created. So we're using the development environment, and what it wrote was this contracts.json file. Now this describes what contracts your projects have and information about them. So for instance, this JSON file has the example contract, and then it has a link to the source. It has the compiled binary and the ABI of this contract. If you're not familiar with Solidity yet, the ABI is an object that describes the variables and functions of a Solidity contract, and this helps Web3 and Truffle better interact with this contract. So again, this bug is here. Feel free to ignore. So what is missing from here is any type of deployment. This contract is not on the Ethereum network. Now, as I mentioned before, we are using our test RPC, which has its own single chain. So when we deploy something, we're not actually deploying it to the Ethereum network, but we are acting as if we are deploying it. So to deploy, it's just as easy as compile. You write truffle deploy, and that's going to it's actually going to perform the exact same actions as truffle compile, but then it's also going to deploy those contracts to the network, and then it's going to rebuild the app. It's going to run truffle build. Now the reason it runs truffle build at the end is because your front end is going to want these newly built contracts. For instance, if you're making changes, you rebuild it, you're going to want those changes reflected on the front end. So if we go back and look at this contracts.json file now, close it, go ahead and get it to refresh, notice that we have an address now. This is the address at which this contract is deployed. So this contract's on the network, however, doesn't do anything. I'm going to move on to show you how to use your contracts. So, in order to show you how to use your contracts, we first need to make this contract a bit more complicated. What I'm going to do is I'm going to write a variable. I'm going to add a variable. So let's call it an integer. It's public, and we're going to name it value. This contract is going to hold one integer that is accessible, and we're going to call it value. The constructor is just for example's sake is going to set this value to 0. Now this is actually unneeded because the default for any variable is for any integer is 0, but let's just make sure it's 0 here. Now we're going to have a new function that says set value, and that function is going to take an uint It's going to take in the new val, it's taking the value of what it should be set to, and then we're going to make value equals val. So pretty easy example. We have a value, has its default as 0. We can set it to anything we want. Now, interacting with this contract is not straightforward, but it's easy once you get the hang of it. So the way that I'm going to start describing how to interact with a contract is through Truffle tests. Now, by default, you get an example test, and the test looks like this. It uses the contract function. Now, you say which contract you want. This is actually only for display purposes. All of your contracts that are compiled are available to every test that starts with a contract. Now, this function, so it takes the contract name or whatever display you'd like to put here, and then it takes a list of accounts. This list of accounts are provided to you by the test RPC, or rather your RPC client that you decide to use. So if you're using Go Ethereum, this will be the list of accounts that you've unlocked. In test RPC, you're given 10 free unlocked accounts, and they all have Ether, so this will have 10 Ether in it, or excuse me, 10 accounts in it. So the current example doesn't do anything exciting. The test says that it should assert true. This is obviously this is the name of the test. It's for display purposes. It gets an instance of the example contract at where example has been deployed, and then asserts true, and then finishes. So this doesn't actually test anything on the contract. However, to show you how to run this test, since it's already here, you can simply type Truffle test, and that's going to go ahead and run through that. Note that this testing environment is using Mocha, which is running these tests, and Chai, which is doing the assertions. So we asserted true. Again, not very exciting, and that's not executing the complexity that we added just a second ago. So I'm going to go ahead and take this assertion out. And again, this line here says that I want to use the example at the address we deployed it to. I will talk about this here in a second, but let's go ahead and write a more interesting test. So we have this gives us a version of the contract at that address that we can interact with. Again, this deployed address is the address that's listed in contracts.json right here. So we can then interact with the contract using promises. So example dot value. Notice that with this contract, Solidity gives you an accessor for value. You can read the value of this variable. So that's what we're going to do. So example.value. Now, when we're reading something from the Ethereum network, we don't need to send a transaction. And in fact, if you send a transaction, it's going to cost Ether, and you can't actually get the return value of that transaction. So instead, we need to do a call, which effectively is the same as a transaction but doesn't persist anything on the network. It'll return whatever the function returns. And in this case, it's a Solidity function called value, and it returns the value of value. So we're going to do call, and this calls the call function and returns a promise. So once call is finished, we can then execute what we want next. Now, call is going to return, or excuse me, this value function is going to return the value. So we'll just go ahead and call the function that it returns value, and assert is true. Actually, assert equals value 0. Value should be 0 after deployment. Now, just to make sure that that this moves on, we're actually going to remove the done function here. put it on the end of this. So promises happen in a chain. So this one's going to happen first, then assert. It'll run this assertion. Then we're going to want to finish up. So we'll do then done. However, we also want to catch errors, and perhaps this could error for some reason. So we'll want to catch any errors as well. But this done function is a normal callback, so we want to send those errors to done as well. So let's go ahead and run this test and see what happens. Okay, so this would actually make sense. I never saved this file. So we got to save the file, and we can run the test again. All right, now we get a better error. This equals should have been equal. So we run that test again, and we notice it passes. Great. So again, we're not doing anything exciting here. So we should probably execute more of that contract. So we can add on to this, and since this is promises, we can add another .then block. Then we're not gonna take anything. Add this on. So what we want to do now is send a transaction. Now notice that we're using promises, which means you can use promise chains, and promise functions or functions that are executed in then blocks can return promises to continue on the chain. So what we're going to do is return, we're going to call the set value function and return the promise that calls. So set value. We're going to set the value to 5, for instance. Now remember, set value is a function. We're not calling .call on set value, which means that we are instead sending a transaction to the network that will persist on the network. And then, since this is a promise, we're returning that promise, which we can then do something with here. So then, now, whenever a transaction is executed, it returns a transaction hash. We usually do nothing. In my tests and in my code, I usually do nothing with that transaction hash, although you can assert that it is valid. However, Truffle uses a library called pudding, and pudding makes sure that when you call transactions like this, that they're actually persisted on the network before the next then block is run. So if you get a transaction back rather than an error, you have fairly good assurance that this transaction went through. Now what we can do is we can verify that. Again, we're chaining promises here, so I'm going to call the value function again as a dot call. But in this case, I'm going to return. In this case, I'm going to return the promise. So return example.value.call. Perfect. Now this is going to do the exact same thing as up here, except it's not doing a transaction. It's calling this function and returning a promise, which we can then handle here. So now, since this is a function that I get the return value of rather than a transaction hash, this value should be what I expect. Now we can assert equal again, equal value 5. Value should be 5. In fact, it's probably better if we take off these periods for display purposes, in case any of these errors actually error. And for the heck of it, it should do, let's describe this test better, it should do more complex, complex interaction. Great, so we're going to go ahead and run this test again, Truffle test. It's going to go through everything, and it passes. So notice that it went through the test RPC. The test RPC is giving a lot of output here. Everything's great. Now everything's passing, but it'd be nice to make sure that things are actually running. So in order to do that, make sure that it fails when it should fail. So for instance, let's compare value to 4 instead of 5. If we do that, we go over here, run Truffle test, and then notice it fails. Value should be 5. Now this is an interesting portion. Whenever you see something like this, object SE, this is what Web3 likes to call a big number, and that's a library that Web3 uses. A big number is a number that can be larger than the maximum size of a number in JavaScript. JavaScript has a limit to the size of numbers that it can handle. So it uses this big number library. When you see something like this, it just means that whatever printed this out didn't know how to get the correct value. If you have big number, you should do a big number value. Let's say value is a big number. Just do value dot value of. If value was the big number, value of will get you the information that you need. To convert the big number to something that you can use in tests. So anyway, let's put this back to 5. And now we have tests running. This moves us on to our next topic, which is actually using these contracts in the UI. So I had talked before about this build process, and that's the process we're going to use for this example. What we can do with what we already have is run Truffle serve. What this is going to do is create a web server that we can then access our files within the build directory. So if we go over here, look in the build directory, we have an index.html, an app.js, app.css. Truffle serve will by default serve index.html. Now, note that the files within the build directory are the result of the build process, and so these aren't files that you want to edit going forward. Instead, you want to edit the files within app directory and continue editing those as you want to make changes to your project. Now, here is the index.html file within the app directory. Note that it includes app.css and app.js. This is written as if it were to be run in the build directory. Also note that has some extra text here. Now, just to show off what Truffle serve can do, I'm going to go ahead and remove some of this text and hit save. And if we go back to our console, we'll notice that it rebuilt the app for us. So what I can do next is go to the browser and hit refresh. And this is the app that we've built so far. So what Truffle does in the background is when app.js, it will automatically add your contract classes to your application. So for instance, this is the developer console. I can type in example, and that's the example class. Oops, that's the example class that I had previously. There's one important thing to note is when you are editing your contracts, they won't be automatically compiled and redeployed for you. You have to do that yourself. So, for instance, if I were to add another function do something, and let's just not have it return anything. Function do something and hit save. You're going to see this the console rebuilding your project, but it's not compiling and redeploying. So if I were to go here, hit refresh, and I do example, maybe I do var e equals example at deployed address, which is the same thing we did in the tests. If I do e.do something, it doesn't exist. Notice that e.setValue does, but do something doesn't, and that's because it wasn't redeployed. So you can either go into a different console window and deploy those, or you can hit Control-C, type Truffle deploy, and then, oops, I didn't mean to run that twice, and then run Truffle serve again, Now, and then once we hit refresh, I can do example at deployed address, and now I have dot do something, which is what we expect. Now, this is a feature that is on the list. We want Truffle to automatically redeploy for you, but it currently does not. So make sure when you're changing contracts that you make sure to redeploy each time. So from here, it's your app to make. So the example I want to show you as far as working with this build process isn't going to be very large, but I'll show you how I generally include dependencies into my project and then go ahead and start using those. So what I'm going to do is hit Control-C, get out of this, and I'm going to go ahead and npm install React. So we're going to use React as a dependency, and it's going to go ahead and get that. And then, so if you notice, you cd node modules, React, dist, there's an actual react.js file here. So what you can do is if you go back to, oops, sorry about that. If you go back to your app.json file, which configures your app and the JavaScript that you need, we can just go up here into app.js and include the react.js file. So even though paths within this configuration file are relative to the app directory, we can still reference files outside of it. For instance, dot slash node modules react dist react.js. So when we do that, we hit save, go back here. Oops, we weren't running Truffle serve. Let's go ahead and hit Truffle serve. One thing, it rebuilds every time you run Truffle serve, but I'm going to go ahead and add a space and hit save, and we'll notice that it does check for changes in your app.json file. So then we can go back to Truffle and notice we have the React class like we expect. So a few other things before I leave you to take Truffle on a spin yourself. Truffle automatically supports JSX files out of the box, and this is because Truffle uses Babel to do its ES6 processing. So this works really well with React. For instance, you can go ahead and create a new file in your JavaScript directory, app javascripts my file.jsx, and then go into this file and say my file. Let's rename this file to my class.jsx, right? So my class equals react.create class, and then you could do something with this. What I like to do then afterwards, I'd like to just be explicit and say my class equals my class. But we can have this React class do something, take this JSX file, put it in our app.json right after React. So JavaScripts, my class.js, put it in there. Notice that, again, go back to Truffle serve. I put that in wrong in the configuration. This is a good example. Add the JSX. It should serve it again, or it should build it again. There we go. And we go back here. Oh, and there we go. Now we have a React error. Just to make this not error, let's go ahead and return a div with nothing in it. Perfect. Back over here, refresh, and notice that my class now exists. So from there, the app is yours. You can use this build process if you want to. Or you could use your own build process. Again, if you use your own build process, you're going to have to get your contracts from the contracts.json file into your front end and use pudding or Web3 to interact with those. But if you're using Truffle and the Truffle build process on its own, you have those in your front end and you can go from there. The last thing I want to show you are a few extra features of Truffle that will make Truffle easy to use. So the first one is Truffle Console. So remember that we had that example class, but let's say you want a console that you can interact with before writing code and executing it through your app. What you can do is just quickly type Truffle Console, and that'll open up this console here that says you're running in Truffle and using the development environment. I'll talk about environments in a second. However, what you can do then is you have access to that example class that we talked about before, and you can say var example equals example dot at example dot deployed address, and there's example, and it has all the functions we expect, and we can interact with it from there. So that's really nice. If you want to use a different environment, just use Truffle console-e and the name of the environment, production, or whatever you want to use. Again, I'll mention environments in a second. The next one is Truffle exec. So let's say you want to write a script that has access to your contracts. You could easily do that. So let's say touch my script .js. I'm going to go ahead. That should be right here, my script. I'm just going to go ahead and say console.log example. Again, this script is assuming that I have access to that example class, and then I'm going to say process.exit 0. Just to show you how this works, Truffle exec, my script, and it'll run this, and it should print that example class, and there it is. So note that this script explicitly called process.exit 0. This is kind of an idiosyncrasy of of Truffle exec right now. If you want your script to exit, you must explicitly call exit. So that's up to you. However, now you can write a script that has access to all your contract classes and have this script run however you want, whether or not it's a complex deploy script or it's a script that you have running on a cron or what have you. The next one, I'm going to go ahead and talk very quickly about environments. The environments here are the files, or excuse me, the folders listed in config. So these come from Rails environments, or the environments in Ruby on Rails, and they have the same names that you would have there. So development would be the default environment, and that's the environment that's used during development. Production is intended for the actual Ethereum network. Staging perhaps is a test network that you share with other people, and test is actually what's used during the automated tests. So each of these directories has a config.json and a contracts.json. Config.json is by default empty. Any config that you add in here will override the configuration within app.json. So for instance, I can say my RPC client is as a host not at localhost, but maybe 192.168.1.27. Oops, 1.27. And maybe I say it runs on a different port, for instance, port 9898. Sure. And maybe that's specifically what I want for development. The contracts.json file is automatically created, but it's important that you manage this file. It's important that you manage this file within your repository. For instance, if this is the development environment, every developer is going to have their own deployed version of contracts.json on their own test RPC, for instance, and so you will not want to check this file in. However, on the production environment, on the Ethereum network, you'll want to save which contracts have been deployed and where they've been deployed to and what their binaries are, because your production represents what's currently out there, and development represents what's currently being developed. So this file you'll want to add to your repository. Staging a test, that's up to you. Test gets overwritten during every test. Every test that's run gets a new contract deployment. And so these will be overwritten repeatedly, so you probably don't want to include those. And staging is not there by default, but is there to encourage a testing environment within your company or group of developers. So one quick little thing you can do with these is that you can rename them to whatever you want. So for instance, I'm going to rename staging to consensus testnet, right? And then maybe I'm going to change the RPC configuration. Again, host is, I'm going to 1, 2, 3, 4, 5, 6, 7, 8, 9. Nope, that can't go. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1. Nope, 2. Right? And then 8, 5, 4, 5. And we could perhaps try to deploy on that. So it's not going to work, but I could say truffle deploy -e consensus testnet, since I have named the environment that. So you have full control over the names. You can rename them to your context. However, I recommend not renaming development, as that's required by many of the features of Truffle. So one last thing I haven't showed you and would like to show you before I leave you to use Truffle on your own is creating new contracts from the front end. So previously we used example.at and then used what the address that we already deployed, so deployed address. However, what we're going to do this time instead is use example.new. Now, example.new is a function that will add a new contract to the network. Since this class knows about the ABI and the binary, we can do that fairly easily, and it'll take care of that for you. Now, before we go ahead and do that, I need to stress that all transactions on your front end need to have a from address. You need to specify exactly who is sending that transaction, and that's up to you. It's not the Coinbase, or may not be the Coinbase, depending on your application. However, what I'm going to do for this example is to make it the Coinbase. So I type that in here, and then here we go. So in order to create a new contract, we're going to use example.new, and what we will do is pass this from address, saying we are going to use that Coinbase address to add this contract to the network. So we pass that in there. This is a promisified function, so then I can do function, and I get an instance of the contract, which is like example before, and then I can go ahead and log that instance. And this will be an instance of example that that you are familiar with. So it looks like I spelled something wrong, so let's just go ahead and do that again. Instance, and there we go. So now I can continue along this path. I'm going to go ahead and say window.instance equals instance to allow me to use it. And then I can do I can use that instance just as I had previously. For instance, window.setValue, as we did in our tests. So there you go. I hope that should be enough information about how to use Truffle. If you have any questions, there is a Truffle Gitter available. Check the Truffle GitHub and press this join chat button, and you should be able to find me in Gitter for other questions. So thank you very much, and good luck. Cheers.